Now let's create a simple graph. We'll use the same approach that we used with trees and linked list. We create a node class, one variable which is value and another variable which will store all the neighbors of that node. Now we are simply adding the nodes here and we are creating neighbors of each node. Now I have already created a print function, print tree function, which you need not to worry about as of now. Now let's try to run this code. As you can see, our graph is ready. Now we have created a simple BFS function. It has one set and one queue. Now we look for if we already find the target inside the queue. If we have, we simply return the path that we have followed to do that. If we haven't find the target yet, now we will put all the neighbors of that particular node into that queue. And for that particular queue, we are already running a while loop and checking every time if we have find the target or not. Let's try to run this code. Here we are trying to find the target or path between A and I. BFS works layer by layer. It first checks layer if the target element is available or present in that layer. Let's say at A, it will check if I is present here. If it is not, it will go to the next layer, that is B and C. If it is still not present there, it will check the next layer, that is D, F, E, G. Now, if still not present, it will go to the final layer, that is H and I. Once it finds the target element, it returns the path between A and I, that is A, C, E, and I. Now let's try to understand DFS, that is depth first search. Again, we'll try to find the path between A and I. Now this is the simple function that we have created for DFS. It has a visited set and a path array. Now we check if we already find the target, we simply return the path. If we haven't, we iterate through all the neighbors and we simply call DFS recursively on that. Let's try to run this code. Here we see that we have already find the target. Now what DFS does differently is instead of searching layer by layer, it pick one node and it goes to the depth to find the target element. Let's say if we start with A, it will go to B, then it will go to D, then it will go to H. Now it will come back, it will go to D, then it will go to B, and then it will go to F. Now this is the core difference between breadth first and depth first search. DFS check the depth first and BFS check the layers first, and then it keep on going down and down. Now this approach of creating graph and using DFS and BFS is okay if you are giving interviews or preparing for interviews, but for production we have to use graph databases such as Neo4j, Amazon Neptune, and Tiger Graph. Google has created its own distributed graph DP, which is highly optimized for routing. This was my day 18 of 20 day data structure series. If you're liking it so far, please like, share, comment, subscribe. Thank you.